I'm going to talk about crowd's knowledge of the crowd as sort of an organizing principle for this talk, but I think a lot of it is motivated by thinking about Duncan's comments on problems and problem-oriented social science. And I think he's a little bit heroic here in its sense. It's a little bit like herding cats. Social scientists do what they want to do, and a lot of the talks will be a little bit of what we do, but reoriented a bit in the direction of problem solving. And I want to throw out problems of different levels that I think are important, and I'll ground this talk in narrower ones. But the overall motivating process is really sort of thinking about reducing what I put in here, quotes, bad inequality. So there's a lot of inequality in the world. We're seeing changes in it. We're seeing it documented. It's something which is problematic. And I put bad in quotes because there are certain elements of it which are going to be incidental and part of any system, and there's other parts which are really fundamentally handicapping and hurt world welfare and efficiency, and those are the ones we want to identify and eradicate in some ways. And what I'm going to talk about is really two more specific problems that fall under this big umbrella. One is increasing accessibility to microfinance, and that was a very specific problem. So essentially what I'm going to do is give a vignette of what Duncan was talking about, where we started with a very specific problem that we needed to solve. We went in, we analyzed it, we built some theory, and we have a suggested solution. And we've tested the solution, and it seems to be working. So it's going to be sort of, here's the problem, here's how we thought about it, here's what we understood from the theory, here's our suggested solution, and now we just, I'll report on some tests we've just been finishing in the last year or two, and it seems to be working. So this has been about a 10-year project, very large scale in terms of funding, but very small scale in terms of these kinds of overarching social problems. The second one is more grandiose in terms of its overarching problem and a much smaller slice, but I think both of these tie together in the sense that the solutions are going to come from understanding what individual people know about other people. And this is going to tie in a little bit, I think, with what Michael Kearns will talk about later on, which is understanding what people know about other people, crowdsourcing, having people solve problems, and in particular, solving these problems is going to involve understanding what people know about other people. So in particular, in microfinance, we're going to be looking at diffusion processes, and we want to be able to identify people who are really good diffusers in a population for getting information out. And we're going to have to rely on the community's knowledge of itself in order to identify those people. And so the question is, how do we identify those people, and how are people able to do that? In understanding homophily, it's going to be a question of how good are people at predicting other people's behaviors, and why might we see people segregating within a society, and how do we understand that segregation, and what are the implications more broadly for inequality? Okay, so I'm going to sort of break this into pieces, and this idea of what people know about their social surroundings is one that has some interesting sort of conflicting perspectives. One is that people actually navigate networks remarkably well. And we've seen that going back to Stanley Milgram's famous experiment of diffusing or getting letters from individuals to targets. John Kleinberg has work on this. Duncan has work doing this with emails and so forth. So people actually navigate networks relatively well, but they have lousy knowledge actually of the networks. So if you ask people to name who their friends' friends are, they can name their friends' friends who are actually their own friends. So I know my own friends, and I can tell you which of them are connected with each other, but I'm not that good at naming who my friends' friends are. And once you go out more than 2 steps, people are essentially no better than random at doing this. So this is work by Noah Friedkin, David Krackhart. So there's a series of things that sort of map out that people don't have good social knowledge. But yet, they're going to turn out to be very good predictors of influence and position of others. And that's going to help us solve a problem of actually getting information out. So we'll be using the population itself to tell us who to talk to, and then use that information to pass information along. The other thing is that they'll actually be good predictors of each other's behaviors, but they're only going to be good predictors of each other's behaviors to the extent that the other people look a lot like them. So I'll report on some online experiments that we've been using, done cross-culturally in India and the US, and show you that people in the US are very good at predicting how people in the US are going to play. People in India are good at predicting how people in India are going to play, but they don't play well across, and they play very differently. So surprisingly differently, they're going to behave differently in a very innocuous sort of symmetric game. So it'll be a fairly simple environment, and they're going to behave predictably differently, and they won't match well up against each other. Okay. So these are online and field experiments mainly, and here we're going to be trying to understand whether or not people can tell us things about each other. And let me start with this first part, which is the long-term projects. This is basically now a decade old, or decade ongoing. So this is work with Abhijit Banerjee, Arun Chandrasekhar, and Esther Duflo. We've been working in southern India and trying to understand how to diffuse microfinance. So that was the basic problem that we started with. And we needed to identify influential people in order to do this. And I put here not just popular people. So there's a feeling that somehow, when there's something which is known as the friendship paradox, if you want to find people who are really popular in a network, ask people to name their friends, and those are going to be well-connected people. So do snowball sampling. Here, that turns out not to be the right answer. We don't want people who are just popular. We want people who are central in a very specific sense, and those are going to be the people who are best for diffusing. So I'll first of all tell you how those people are central, and then what we're going to have to do is actually rely on people to identify those individuals. And I'm going to give you some theory as to how they might be able to do that, and then actually show you that this actually works. So let me give you some sort of background on the overall project so you understand why we were doing this and what the problem really was. So this is all in Karnataka, roughly 100 to 200 kilometers band around Bangalore. We were working in relatively poor villages, so these are rural villages. Typical villages, about 1,000 people, 200 households. And the villages are agricultural, some dairy production, relatively poor, about $1 per capita income. And the problem was the following. So there are microfinance organizations entering these villages. They're trying to get microfinance products out. So these are small loans that are non-secured loans that are very productive and useful for the population. And the problem that they were facing is they would go into some villages and get nobody to take up. They would go in other villages and get substantial take-up. So they were getting wide variation, and these had been identified as more or less identical villages from the bank's perspective. So you're getting very similar villages, but very different outcomes. And the question is sort of, why is that happening, and could they improve the outcomes? So is there a way for them to go in and actually make sure that the microfinance is getting out to the people who need it in these villages? And so the first part was sort of identifying why they were having this problem, and they were getting news out by word of mouth. And so it turns out that the centrality of the first people that they talked to in these villages is a substantial predictor of whether or not they get things out. And so they had a particular way in which they tried to identify central people, but it turns out that they weren't that good at doing it. And if they happened to hit central people in a village, things would take off, but not otherwise. So then the real problem was, well, how can they find central points without network knowledge? So we went in and actually mapped out networks, but that's very expensive. The bank doesn't want to do that on a regular basis. So how can they find the right people to talk to without actually going in and surveying villages and mapping out social networks and collecting a lot of data? So the question is, can we tell them, here's a recipe for solving this by finding the right people in the village? And basically, can people tell us? And I'll explain why we think they can tell us and how that actually works. Okay, so we went into the village. This is a typical village. It's roughly 200 households. The individuals are the points here, and we mapped out the networks in the village. So we have asked them 13 different questions. Who do you borrow from? Who would you go to borrow 50 rupees for a day? Who do you go to temple with? Who do you ask for advice? Who comes to you to buy kerosene and rice? borrow kerosene and rice, who do you go to in an emergency for medical help. So we had a lot of information. And then the kind of what we tracked over time was that the bank would come in. The bank's algorithm for trying to diffuse information was to tell their employees, find the shopkeepers, self-help group leaders, and teachers in the village. So they would go in, find those people, might find several of these nodes, and then tell them to spread the information. And what was happening is in some villages, the teacher might be out here. In other villages, the teacher was in a central position. And so the question is, first of all, how do you measure centrality? How do we identify these individuals? Can the bank do better than just looking for self-help group leaders, teachers, and shopkeepers? And they deliberately stayed away from politicians. I won't go, the caste politics and so forth are tricky here. So there are reasons that they were using these as the categories. They thought these would be well-connected people. Turns out they weren't that well-connected. It was pretty noisy. So can we do better?
I just had a clarifying question. Are the edges here between households or individuals?
So the edges are going to be between individuals. So we surveyed, so now we have surveys about 94% of the adult population, so anybody over 18 in these villages. But what we're going to do is aggregate things to the household unit, because households were the ones that could actually take out loans, and so the diffusion process was more or less at a household level. But you can treat the data either way. And you can find all these data on my website if you're interested.
Where do we need central people, central individuals?
Right. So basically, let me show you what the process is. I'll sort of give you a theoretical process and then explain why we're looking for central people. So the bank comes in, and what it's trying to do is say, look, we're a bank. We're going to want to get out information about microfinance. These are relatively poor villages, so there's not people don't have internet connections. Some of them have cell phones. SMS it's mostly spam, so people don't pay attention to messages you send. So it's hard to get news out, so they're doing it by word of mouth. So they go in, they tell somebody, look, we're the bank. Tell your friends that we're going to be back in 2 weeks. There's going to be a meeting, and then information spreads, and then some people show up and then take out loans. But the information doesn't necessarily spread that well, right? And so the idea would be, let's think about a diffusion process. Let's say a simple SI process. And let's define centrality by just defining a diffusion process. So here's a simple, let's suppose that people talk to their friends with a probability 0.5. If I tell you about microfinance, you tell your friends with each friend that you bump into in a given time period and with a probability 0.5. And let's think this operates for some number of periods. So we can have a diffusion centrality measure which says, how frequently do people talk about this subject, and how long will they talk about it? And so now we can just simulate. So here's a node that we pick out of our village, and we say if this was the first node informed, let's simulate for 4 periods. Well, they happen to tell one of their 2 neighbors in the first period. This goes on and so forth. And then after 4 periods, they've told 13 people. So we can say, OK, well, this node would be worth 13 in terms of diffusion possibilities if this were the process. If it's a pretty good spreading process, and it lasts for about 4 periods. Now, in our data, P is actually going to turn out to be about 0.2 as a good measure, and roughly 3 is going to work out for microfinance. But this, we give an idea, so we'd have a number for this node. You could do another node, work it out, and you'd get 6 people knowing. So now look, if they can find this node instead of this one, they're going to do twice as well in terms of getting information out. Okay? So this is just a really simple way of defining centrality, which is based on a very specific diffusion process. Okay? And you can show that this centrality measure actually, when t is 1, this is just going to be proportional to degree, just popularity. As t goes to infinity, this is going to begin to look like eigenvector centrality if the p is high enough. So and it has relationships to Katz-Bonish centrality. So we have some theorems on this, but this centrality measure is related to a series of other ones. And people have looked at things like this before. So there's a cascade process by Kempe, Kleinberg, and Tardosh. There's other, so this is a sensible way to think about diffusing, and we use it as a centrality measure. OK. So first of all, if we look at the microfinance participation in the villages and just look at what predicts it, so these are just regressions of microfinance, and what is on the side here is the centralities of the first informed people that they talk to in the village. So we actually know the networks, we know who they talk to, and we can see what the microfinance outcomes were, and we can measure sort of what the diffusion centrality of the different individuals that they talk to is. So we measure that. We can measure eigenvector centrality, you can measure degree centrality, closeness, pick whatever way you want to define centrality. And here you get a highly significant relationship between microfinance participation and diffusion centrality. So, I think the important numbers are down here. So what percentage of the variation do you explain by looking at these different measures? Diffusion centrality actually does much better than the others. It's not surprising, it's a richer measure, but it does much better than the others at predicting, explaining the variation in terms of what's going on.
Explain those covariates, like in terms of what do you define as participation in microfinance? Like just the bottom.
Sure. So what we looked at, the dependent variable is microfinance participation in a village. So we have 75 different villages we looked at. So actually 43 I'm going to use in this data set. So these are 43 of the ones that the bank had entered by the time we stopped this part of the study. So the dependent variable is what percentage of the population in that village ended up taking up microfinance. And then the independent variable here would be diffusion centrality of the first nodes that they talk to. And then the
taking up microfinance. So it seems like you have some specific criteria for what taking up.
No, so these covariates are just, we also control for how many households are in a village, whether, what's the percentage of people involved in self-help group. So we use some lasso regressions to figure out what other variables to put in.
What does it mean to take
Sorry,
up?
yeah, so microfinance is a, sorry.
I've worked in South India for 15 years in microfinance. I know what it is. What does it mean to take up in your study?
To participate in a loan with this bank. So there was one bank that these villages had not had a bank entering before. Participate in microfinance means this person took out a loan.
SHG is not a covariate. That's actually already participating in microfinance.
No, SHG is just that there were self-help groups in these villages already.
That's already a form of microfinance.
Yes, but I'm talking about formal microfinance coming from a Grameen style. Yeah.
And what are edges again?
Edges are going to be in that two households are connected in one of these networks. So for the purposes of, we're going to use the union of all of these networks for that regression. The network was based on answers to all these questions that we asked them. Who do you go to for advice? Who do you borrow money from? So this is one village out of the 43 in that data set. This is the advice question. This is the temple question. We'll put two households to be linked together. If they answered yes on any household or any question, that's roughly degree about 15 for a household out of about 220 households in a data set. So they're talking to about 1/15 of the other households on average in the data set we're looking at. So it looks denser in these graphs, but it's actually a fairly sparse graph when you really get down to it. Okay. So what we have is that diffusion centrality predicts microfinance. Eigenvector centrality is also a reasonable predictor. Eigenvector centrality is running diffusion centrality off to many periods. So it seems that this is actually a diffusion process that lasts. People talk a few times, but don't talk for t equals infinity. Okay. So now the problem is we want to solve this for the bank. The bank's getting lousy results. Sometimes they're getting good numbers. Sometimes they're getting bad numbers. They want to reduce that variance. They don't want to go through and did what we did, which is map out these networks and then ask everybody and then find essential people. They want to find essential people otherwise. So the question was, could we just ask people? We'll just ask them. And obviously, we're not going to ask them who's the most eigenvector central or diffusion central person in your village, but we could ask them, how would you actually, who should we talk to diffuse information? And so that's what we did. We just went in, we asked adults in the villages, who are the best people to start diffusion, and then we'll try and see what happens. So the questions we asked in particular were, if we want to spread information about a new loan product to everybody in your village, who should we speak? And then we also asked, if we want to spread information to everybody in your village about a music event, drama, or fair, who should we speak? And we wanted to ask two questions to make sure that they weren't answering differently when they thought it's a financial product that might be exclusive versus something just about a music event or fair that was going on. It turns out that the data are almost identical for these, so I'm not going to show you that both they're more or less identical. Okay, so first of all, these are looking at a given village, ask how often a particular household is nominated by other people. So how often does a household point to this household? And then look at what the diffusion centrality is. So this is just a diffusion centrality against how often you're nominated. Okay, so not surprisingly, the ones that are getting very high numbers of nominations, in some cases they were named by almost everybody in the village, are highly central. So you get a positive relationship between the diffusion centrality and whether or not people are nominating the given individual. Conditional on being nominated, the median number of times being nominated is 9. So a lot of times they're naming the same household, and they seem to be naming people who are highly central. And you can sort of look at this sort of breaks things down by saying, okay, what share of people were both nominated and have leadership status? So our self-help group leaders, shopkeepers, or teachers. So if you look at those, the people who are nominated and leader, what's the probability that they're in the top 10 percentile of centrality? And roughly, there's almost a 50% chance that they're in the top 10 percentile. If they're nominated and not a leader, that goes down to about 25%. If they're a leader but not nominated, then that's down to about 18%. And if they're not nominated and not a leader, then there's about a 10% chance that they're in the top 10%. So they're a little worse than 10%. So basically, they're picking out individuals who are highly central, and they're doing it much better than the bank would have done alone. And if we put together leaderships, some demographics plus their nominations, then we're able to find the people who are highly central. So it doesn't take us long to find people, especially if we start looking for people that are nominated multiple times. Okay. So just a quick theory. I'll spend a minute or two on this. So how is it that people are actually able to do this? So why would this actually work? So I told you before that people can't really map out their networks. They can't tell you which of your friends are, who are your friends' friends. So how are they able to pick out people who are highly central that are often two or three steps away from them? So the idea here is just gossip. So imagine that there's information spreading through the network by the same kind of process that the diffusion process worked by. And so what's going to happen is people are just going to get information periodically. Arun moved to Stanford, Matt has a new MOOC, Esther won an award. So this kind of information is spreading about nodes. And I just keep track in my mind of over time, I just keep track of how often I've heard about Esther, how often I've heard about Arun, Matt, and so forth. So I just have this mental thing. This is a person I hear about all the time. And what I do is I infer that person must be highly central, because otherwise the news couldn't have reached me in the network. So flip this upside down. Instead of asking who's a good diffuser, now from a listener's perspective, how often do I hear about different people? That's going to correlate with the diffusion. And so what you can show, it's not hard to prove a theorem which says that you take any connected and aperiodic network, every individual's hearing of others under network gossip converges to diffusion centrality, as long as this probability of talking is at least 1 over the first eigenvalue of this matrix, which is non-negative or is positive in this case, and real, and t is large enough. So if people talk, if you're in this village long enough and you're a listener, then what's going to happen is you'll be hearing things in proportion to how central individuals are. And so if I just keep track of how often I hear news coming from Duncan and from Sinan and from Michael and so forth, then eventually I'll be able to rank them in terms of how good they are as spreaders. So it's not hard to prove that. So then what we did is say, okay, we can't diffuse microfinance because we're not a bank. But what we could do is try a different experiment and see whether the people that they're actually telling us would be as good as just picking leaders, and how well would it perform. So what we've done now is we went back in just 2 years ago. We've found 210 villages that weren't in our original sample. 70 of them, what we did is we gave away cell phones by randomly seeding the villages, just picking at random 3 or 5 people to tell. 70, what we did is we looked for village elders or village leaders within those villages. And 70, what we did is we used the gossip. So we actually went in, asked people, who should we use for diffusion, and then used those people, 3 or 5 of those people for diffusion. Okay? So now we can look, how well does random work, how well does using some sort of leadership status work, and how well does using nominations work. And This is just the random seeds. So each one of these is a village, and then this is the number of eventual cell phones that we gave out. And roughly, there's reason there's 1, 2, 3, 4, or 5 different numbers of seeds. Sometimes we happen to hit all 5. That we tried to find 5 people, all 5 were available. Sometimes only 4 of them were available, sometimes only 3, and so forth. So there's a distribution of how many initial points we had, which just depended on availability.
Just a question. When you ask people, go in and ask people to do the gossip experiment, you ask everybody or just a small subset?
No, so we picked 15 households. So we asked 15 households, and then out of their 15 nominations, we randomly picked 5 or 3. I mean, depending on the treatment, yeah. So this is what happens if you use the leaders. So the numbers are better. So the average is better, but still not great. And then when you use the gossips, you get basically 2 to 3 times what you got if you had just used the random or the leadership status. So they're able to, so they're telling us people who are central, and when we use them, they're actually doing much better than if we just use leadership status as a predictor of the centrality. Here instead, they're telling us, and in fact, I won't go through it, but it seems that they're telling us they predict centrality, but they also are predicting other things about individuals. So there's other attributes that individuals have that might make them good news spreaders that people are able to incorporate into their answers to these questions that we're not picking up necessarily by just looking at the social structure. And our social structure might not be the right one. We're using a very specific measurement. They might be doing even better than we could. And you can look at these distributions are strongly different from each other in terms of a statistical sense. The p-values are basically zeros for looking at the difference in distributions across the villages. Okay, so what that told us is, here's a problem, we want to spread information, how do we do it? And people can help tell us, and we have some theory as to why that works, but it seems that that's sort of one coherent story of diffusion. I want to just talk very briefly, this ties together a little bit. This is a work with Yiqing Xing, who's a student at Stanford. And what we looked at was trying to understand what people know about other people's behaviors, not just their social position. And in particular, can they predict other people better than at random? And I think, sort of thinking about this, I also want to point out, why do we worry about this? This goes back to a problem. We sort of put this in perspective. Think about busing that went on in the 1970s and various proposals to integrate high schools. So when you look at what happened, the idea was we'll build large high schools, and within those large high schools, if we build larger high schools and are combining populations, we'll be able to build balanced high schools that are integrated. Well, when you actually go into those high schools and look what happens, when they built large high schools that were well balanced in terms, the better balanced they were in terms of the populations, the more segregated they turned up in terms of the friendships. So I've worked with Sergio Corini and Paulo Pin, and when you actually look inside those high schools, they tend to be highly segregated. So this is a picture of one of the high schools from the Ed Health data set by race, and you can begin to see that there's very few friendships across races in this data set. And so what happened was, they would build a large high school and people then would self-segregate. And so part of what we want to understand is what drives people's instinct to connect with other individuals. And there's a whole series of reasons. But one thing we wanted to figure out was maybe this is partly due to the fact that other people who are very similar to me are predictable. I live in the same world. It's not only that I can communicate with them and we have shared cultural values and norms, but I can actually predict how they're going to behave. And so what we did was we looked at, we did this on Amazon Turk. We collected data from US and Indian population, so it's 54% US, 46% Indian population. And we had, so the advantage of sort of crowdsourcing and using Mechanical Turk, we used 1,300 subjects. Then referees said we were paying too little, these were economists. When you're paying subjects on Mechanical Turk, you're paying them very low wages, so they said, we don't believe your results. So we did an extra 80 at 10 times the stakes, and basically the results are identical. So 15 minutes, all inclusive, the earnings in the main part are $1 to $3. And we had them, pass some tests to make sure that they understood the questions and weren't just answering randomly. And then the ones that passed, the 1,300 are the ones that passed and then went on to the rest of the test. So, we have an age distribution. The advantage of using mechanical Turk and so forth, you have less control over observing your population, but you get a much wider population in terms of their demographic characteristics. So you don't end up with these sort of weird characteristics, as Joe Henrich and all call them. We're not just getting Western, rich, educated individuals from universities, but we're actually getting a richer population. In terms of the difference in, we get religious variation. U.S. is actually mostly non-religious. Christian is the main. Then India, it's mostly Hindu, some Muslim and Christian behavior. So we can look at different demographics with this size data and begin to figure out what drives the behavior. So let me just show you the game they played. Very simple game. So it's basically a battle of the sexes game with an extra option, which was an equal option. So they could so they were paired into individuals. Actually, they're individuals matched against a randomly selected person from the population. They're going to choose a color. And based on that, then they're going to get a payoff. So the first is the row player's payoff. Second is the column player's payoff. Here, there's 3 Nash equilibria. But it's set up so that there's one sort of equal payoff, but that the total is higher if they go for an asymmetric one, but the asymmetric one advantages one player strongly, and then there's less advantage for another player. So here, it's hard to predict exactly how people are going to play, but it could be that cultural backgrounds in terms of inequality or equality will drive people to choose different things. So it might be that we sort of go for the equal option because that seems focal to us, or it could be to say, okay, look, I'm pretty sure we're going to go for something unequal. Who's going to win? And we go more head-to-head. And what we did is we also gave them a correlating device. So we have the same results for non-correlating devices. But what we did was we also gave them a prompt where we just said, you and the other person that you're matched with are in a room that's painted either purple, orange, or green. Okay, so this would allow them with 3 questions. It's hard to know whether they're going to coordinate well. This would allow them to coordinate. So theoretically, if you see purple, then you might think, well, the other person also saw that we're in a purple room. Maybe we're going to play purple, and so forth. Okay, so what it looks like. So let's look at the green prompt. So the green prompt is the one that says you're in a green room. And this is what happens from the US subjects when they're prompted green. This is what happens for the Indian subjects when they're prompted green. So you can see that there's a strong difference. The US subjects are going for they actually play green. They go for the more equal. The Indian subjects were tending to go, more of them went for the one that was advantageous to them. Some went anticipating that for the less advantageous, but fewer of them went for the green. So you see a strong difference in these populations.
What was the prompt again?
The prompt was you're in a green room. That was all. We just said you're in a green room and you're playing this game. We didn't tell them play green or anything like that. We just said you're in a green room. So
What does that mean?
that's how, whatever you want to interpret it. It was just a prompt. It just said you're in a green room and you're playing this game. That's it.
Priming or something.
It was priming. It was a sort of a way of priming green behavior. Okay, so let me just wrap up then. So basically the asymmetric prompt, if you prompt for asymmetric, then you'll get the US population to go more asymmetric, but they're still staying much more, they still stay with the green much more than the Indian population. And you get differences in terms of whether they go for the, whether they're disadvantaged, whether they go for the high payoff or the low payoff. And these are all highly statistically different across the populations. And interestingly, when you ask them, so now let's ask them, so we ask them, what do you predict the other person's going to do? And what do you predict they're going to do if they're from India? And what do you predict they're going to do if they're from the US? And what you get is the US population predicts that the other people are actually going to behave similarly, whether they're in India or the US, which matches up with the way that they're playing. And the Indian population thinks that either population is going to play the same regardless of whether they're Indian or US, but they still think that they're going to play like the Indian population plays. So people are predicting that the other population is going to play like they do, and they're not able to distinguish the play, but they better coordinate with their own population. So this would be one thing of, why is there homophily? Well, I'm good at predicting my own population, I'm lousy at predicting the other population, and I do better when I play against my own population. So both populations got higher payoffs playing with their own population. Okay, so broader messages. People may not be able to draw their networks, but they can coordinate with similar others. They can name highly central individuals. This actually helps us to solve a very specific problem. This might give us insights into understanding a more general problem. And people can easily learn these things, even though they don't know the specifics of the networks around them. So thank you very much. I think that's a good place to stop.